Good day, everyone. Today we shall be considering circular motion. And under this study, we shall be considering introduction to circular motion, terms used in circular motion, horizontal circular motion, and exercises on horizontal circular motion.
Circular motion. This is the motion of an object in a circular path. Now let's look at terms used to describe object moving in a circular path. One, angular distance, represented with theta. This is the distance measured in degree or radian an object move in a circular path. So this distance an object move in a circular path, but it's measured in degree or radian. Again, we have another type of distance, which is linear distance. This is the distance an object moves while an object covers while moving in a circular path. Now it's measured in meters, represented with S. Now take note that linear distance and angular distance are related, and that relationship is given as linear distance is equal to radius times angular distance. So if an object is moving in a circular path now, let's assume it moved from point A here down to point B. The distance from here to here, which is the arc of the circle, is the linear distance. While distance as measured in angle, it covers is the angular distance. So this is the angular distance, while this is the linear distance. And like I said, the two are related by linear distance is equal to radius times angular distance. Next is angular velocity, omega. This is the rate of change of angular distance with time. So it's represented with omega. That's not W, it's omega. Omega is equal to change in angular distance over change in time, or angular distance over time. It's measured in rad per seconds. Next one is linear speed. This is the rate of change of linear distance with time. So velocity, linear speed, is represented with V actually. V. So V is change in distance over change in time, or distance over time. Now, it is measured in meter per second. That's for linear speed. And a relationship exists between linear speed and angular speed, or angular velocity. The same thing. That relationship is given as linear speed is equal to angular speed times radius. So we proceed to other terms. The next is centripetal acceleration, denoted with A. This is the inward acceleration of an object moving in a circular path. It is measured in, it's also called normal acceleration. It's measured in meter per seconds. And it has a various relationship. A is given as V square over R. And we can substitute this V. Like I said, A is V square over R. But remember now, V, we gave V previously, that V is omega R. The relationship between linear speed and angular speed is V is equal to omega R. If we substitute that here, this will give me, instead of V, we have omega R all squared over R. Eventually, we have, if we open this bracket, omega squared R squared over R, and R eliminates one of the R here. So you get omega squared R. That accounts for this second formula. Again, you can say that from this relationship here, that radius is equal to V over omega. If you substitute that into this formula here, we'll get that A, which is V squared over R. Now, you can say your R is V over omega, and that will be equal to V squared over V over omega. This omega will jump up, and this V will eliminate one of this V. So this V will cancel one of this V, and this omega will jump up, and that will give us omega V. So that's how we have this relationship. So that's that about that actually. Next is centripetal force. This is the force that keeps a body moving in a circular path. That force is given as mass times acceleration. But remember now, these are the various formula for acceleration as well. So it can also be, instead of using A, you now put V square over R. It can be in this form. It can be M omega square R, and it can also be mv omega, depending on what you are given, the parameters given in the question you want to solve it first, you want to evaluate it first. So next is frequency. This is the number of oscillation or revolution an object undergoes in 1 second. So frequency is number of oscillation or revolution per unit time or per seconds. So that's that about frequency. It's measured in hertz or revolution per seconds or per seconds. Next is period. This is the time taken to complete one oscillation. So when something makes one oscillation, one circle, or one revolution, the time it took is what we call the period. So period is T over N. I want to also say that the period is related to the frequency. The frequency is 1 over period, or period itself is 1 over frequency, and we can see that in their formulas. Why this is T over N, this is N over T, we can say this is inverse of this, since their formulas are inverse of one another. So let's look at relationship now. Relationship between frequency, period, and angular velocity. So relationship now between omega, frequency, and period. We know, we've stated earlier that omega is angular distance over time. But for one complete oscillation now, that is the angular distance covered, that is 2 pi. The time T is the period, which is capital T. So in that case, angular velocity will simply be 2 pi and the time will be T. So this gives the relationship between angular velocity and period. But again, or also, period is 1 over f. In that case, angular velocity omega will be 2 pi over 1 over f. This f will jump up. Omega will become 2 pi f. So this is the relationship of this. So that's about types of circular motion. Well, there are 2 types of circular motion. One is the horizontal circular motion and the vertical circular motion. I want to illustrate these 2 types of circular motion now. See, with this now, if I while in this manner, for instance, this is horizontal circular motion in an horizontal manner. Not necessarily just above my head, it could be just in this manner, but just like this. And this is horizontal circular motion, just moving in it in a horizontal manner. Now, if I while in this manner, this is vertical circular motion. So while this is vertical, the first one is horizontal. This is the first one, horizontal. This is horizontal circular motion. So we have horizontal and we have vertical. So take note of that. Another thing I want to say is that, you see, with this cord now, let me assume that the length of this cord is 50 cm, for instance, 50 cm. If I wire this thing in a circular manner, either horizontal or vertical, the radius of the circle it forms will also be 50 cm, because understand now, radius means from center to circumference, and this is the circle it forms. So this is the radius of the circle it forms now, which is same as the length of the rope. So take note that the length of the rope is same as the radius of the circle. You can see that as we form the circle now, the radius of the circle is the length of the rope. So take note of that. Well, let's take a question now. Example 1. So we're taking firstly horizontal circular motion. So I believe you understand what horizontal circular motion means now. It's wild in a circular manner. So example 1, a body moves along a circular path of radius 5 meters. So to solve this question, first of all, we write out our given. We are given the radius 5 meters with a uniform speed of 0.6 rad per second. The moment I see this rad per second, I remember that this is angular velocity. So omega 0.6 rad per second. Now we are asked to obtain the speed of the body around the circle. So what speed are we looking for? Obviously, it cannot be angular speed. We're already given that. It should be the linear speed, v. So this is required. We can say v is equal to omega r. Then v is equal to, what's my omega? 0.6 times, what's my radius? 5. If we multiply this, we are going to get 3 meters per second. So that's that for this question. So let's solve this now. Example 2. If a wheel 1.2 meter diameter rotates at 1 revolution per second, calculate the velocity of the wheel. Well, the given here is the diameter, which is 1.2 meter. Okay, so I'm going to get my radius, which is diameter over 2, which is 1.2 meter over 2, and we get 0.6 meter. Again, we are given the frequency, because you can see the unit now, revolution per second. That's the frequency. Frequency is 1 rev per second. So we are looking for velocity, which is the linear velocity v. Well, let's calculate firstly angular velocity. We know angular velocity is omega, which is equal to 2 pi f in this case, since I have my frequency. So this will be 2 times 3.142, which is the value of the pi, times frequency 1. This will give us 6.284 rad per second. Next, it will now get my linear velocity v. V is omega r. This will be omega 6.284 multiplied by radius, which is 0.6. So this will give us 3.77 meter per second. Example 3. A body moves along a circular path of angular speed 0.6 rad per second. So the given here now, 0.6 rad, angular velocity, 0.6 rad per second at a constant speed of 30 meter per second. That's the linear speed, 30 meter per second. Calculate the centripetal acceleration of the body towards the center of the circle. Well, we have to get the A. Obviously, A, we use the formula here, V omega. So my V is 30 times the omega 0.6, and that gives us 18 meter per second square. That's that about that. Example 4. A boy ties a stone to the end of a string, which he then winds above his head around the circular path of radius 15 cm. If the stone makes 20 oscillations in 10 seconds, calculate the angular and linear speed of the stone. Well, we are given the radius to be 15 cm. But this physics, we have to use our SI unit. So divide by 100 now. That will be 0.15 meter. If the stone makes 20 oscillations, that is number of oscillations, and is 20. Calculate in 10 seconds, that's the time. Calculate the angular and linear speed. So the first thing I will do here is to go and get, since I have n and t, go and get our frequency first. we are required to get omega and the V. So we can get our F first, which is N over T, frequency, which is 20 as number of oscillation over time, 10 seconds. This will give me 2 Hz, or 2 per seconds, or 2 revolution per second, 2 Hz. The next one is to go and get my angular velocity. Angular velocity is equal to 2 pi F, the first required one, 2 pi F. So that will be 2 times 3.142, then times frequency, another 2. So this will give us, well, 4. Let's change this to pi. This will be 4 pi in rad per second. So you can substitute your pi as 3.142. You should have been about 13 point something. And the next one is our V. V is omega R now. So that will be 4 times, sorry, 4 pi, then times our radius. The radius is 0.15. So this will give us 0.6 pi in meter per second. So this is our V and this is our omega. So that's that for this example 4. Example 5. A spring makes 60 revolutions in 50 seconds. Calculate the period and frequency of the vibration. So here we have the given now. We have number of oscillations, 60 revolution, and then the time, 15 seconds. So we can tell our frequency, which is the required, and period as well. Frequency is N over T. The N is given as 60. The time is given as 15. So this will give me 4 Hz. The next one is the period. Period is 1 over frequency. So that will be 1 over 4, which is 0.25 seconds. So that's that about this example 5. So exercise, we have just 2 questions here and their answers are written over here. So you can try them and try to get these answers. So we next look at vertical circular motion.